Well, here's something different. It's a Heathkit electronic Morse key. So it's one of these with the paddles that does the dots and the dashes automatically. I've always used a straight key, and I think with the advent of people using computers to decode Morse, it might be better for them if I use an electronic key, if I can manage to get on with it. So I bought this from the United States, and so, of course, it is, well, it's got lots of connections on the back. I'll have to make up a fly lead to the radio. Then there's a headphone socket, because you can use it as a practice oscillator. So it comes with a 110 volt plug, or whatever volts it is. So I've got a handy 45 watt transformer, which we'll just plug that into and probably make the microphones rattle. I did just power it up in the living room when Mr. Chippy opened the box, and nothing happens. I don't know whether it's valve or solid state. So that's off, that's on, and that holds it down, so it should be a constant tone one would expect. I might be wrong. It might not do a side tone without being linked in for it. So what we'll have to do is to open it up and see if there's anything obviously wrong with it, or whether it's me who just doesn't know how to work it. And we'll have a look at the instructions. I've no doubt I can download the original Heathkit manual to originally build for the original build. So I'll pause the video and I'll open the case up. So going back to record, so you've got quite a heavy chassis with the switch arrangement on it, and then we've got a printed circuit board which, interestingly enough, wasn't mounted. So it sounds like somebody's had it apart. I'm not saying the person who sold it me knows it's a non-work. I mean, it's sold as you know, spares and repairs, and that's all fair enough. So we've got all the transistors are in sockets. Now that transistor is missing. So it's not going to do what it should do with the transistor missing. I'll just make sure it's not in the bottom of the case. No, it's not in the bottom of the case, so it's been removed. So when I switch this on, I can't expect it to work. Now, if these were British capacitors, they would be, I think the word is knackered. So we'll just see what volts are around on this product. I thought it could even have been valved. I think the late 1960s. So without looking at any circuit diagram, we've got a mains transformer here, which is 110 volts, of course, and we've got some diodes here, so that's the way it's rectified. So I wouldn't be surprised if between there, we've got 18 volts there. So perhaps across these capacitors we've probably got 18 volts, 16, 17 volts. So yeah, we've got some volts there. So I think the thing to do is to check the transistors that are in it, and then we've got to find a transistor that's going to work, or order a transistor that's going to work in this space where transistor 11 is missing. So I'm sure, yes, we have got, no, that's an ESR meter. We've got quite a range of the peak instruments. So we'll switch that off. So yeah, it's, oh look, haha. There's a crack in the printed circuit board. Now, of course, with this being rattling around and having come all the way from the States, that wouldn't have helped matters either. So whether or not it's affecting on the other side as well, no, look, the crack's been previously repaired. So that's happened before I've acquired it. I don't think it was cheap. I think it was 45 quid and probably about the same again in postage. But I particularly wanted it to it'll go nicely with my 1960s Heathkit equipment, and I'm sure it'll work fine when we can sort it out. So right, we forget the crack. That looks okay. So we may as well start with the first transistor. We don't even know if they put them in right. Ah, yes, they are. The spacing is such that you can't get it wrong. So it's an RCA 2N407. So we'll connect up to the transistor tester. And it's a PNP transistor, and you'd expect some leakage, and there's a bit. So that's a good start. It's handy that these are pluggable. And of course you could have dirty connections which would also make the thing not work. And of course the missing transistor, it may not be in a critical part of the circuit. You know, this thing's going to generate dots and dashes. It might be that it just doesn't generate dashes or doesn't generate dots because of the missing transistor. I don't know where it is in the circuit. Again, that's a PNP transistor. Not quite sure why it went off then. There's the battery going flat. There's some leakage which you expect. So put that one back. So this is an NPN transistor, says the board. And it's the flat side to the right. NPN transistor, no leakage. Perhaps it's silicon. So we'll put that one back. We'll try and put that back. And the next one is the flat to the right again, and this one tells us emitter, base and collector. NPN, try again. So emitter, it should be from the bottom, emitter, collector, base. So blue is emitter, red should be collector, and green should be base. So yeah, that's right. So put that one back. So we'll go over to the next transistor, which is a PNP. And there we are, that's fine. Another 4 and we're down. PMP. That's okay. So now we're moving on to 2N407 PMP. I'll look up the spec of the missing one. If I don't expect for 1 minute I've got one in stock, but I'm sure we've got something close by. And I've got Tower's International Transistor Selector book, so we'll find out what it should do. I don't think it's going to be critical, to be honest. It'll need to be silicon or germanium or PMP and NPN. That's probably about all we need to worry about. Yeah, that's okay. So 3 to go. See, that looks to me like the audio output transformer. So if that transistor's missing, there's not going to be any sound, is there? So there's some good logic. PMP. It's fine. PMP, fine. We've just got the big one. I'm going to check the polarity of this because it has the leads bent in a specific way. So that's something we can check. How it should be is on the printed circuit board. PMP. So we've got emitter on our red is collector, and that's the bottom. Our blue is the base, yes, and the emitter is the green. So I've got that right. So we just need to sort out what that is. I'll pause the video and we'll have a look. So what I've just done is to change the capacitor which is missing from there, which was 0.05 of microfarad, so that's done. We've put a NPN transistor, a random one, and I'm still getting no audio out of this item. Don't think I am anyway. Mind you, these knobs are so stiff I can hardly tell. So we do need to look into that further. But what I thought I'd do, I'll hook up our Morse practice oscillator to the output of the Kia. And if I switch that on, so we've now got well, we'll get there somewhere. That's going to take some practicing, isn't it? So we're getting there. It's actually now working. So obviously between that, I think that with that capacitor being missing there, we'd got a bit of a snag. So heading in the right direction. So we just need to, I say, see if we can get the internal oscillator to operate. So I'll disconnect our practice oscillator. So really, all there is the transformer and 2 transistors to make up that little amplifier. So as long as that transformer's not open circuit, it shouldn't be too difficult to track down the snag. I know what I can do, and that's swap. I think it's the same type of transistor from there to there. So I'm just tempted to swap those over. No, we've still got nothing by doing that. So we'll pause the video again and have another look. But at least it's working now, so we can actually use it, even if we can't hear it from its own internal oscillator. Okay, so going back to record, got the circuit diagram off the internet, and of course changing that capacitor I had to change, which was missing, broken, missing. Can't remember where that was on the circuit. So we've got the audio clamp is the transistor 11, which was missing, and what I've done is I've put a random NPN transistor out of a scrap Amstrad chassis, and I've put it in transistor 6's position, which does the dash. It works absolutely fine. So the transistor there into the more critical position there, and I still had no joy. So then I thought, I wonder if the output transformer is faulty, because there's always a possibility. And I thought, well, I'll check the speaker's got some kind of ohms across it, which it had. But I noticed from the meter I got a little click in the speaker, and I thought, well, that's not normal. So I wondered if it wasn't being earthed through the headphone socket. I was absolutely right. The switch in the headphone socket, because it obviously switches out the speaker when you plug in a headphone jack, the switch was bent. So now, through its own speaker. So the job's a good one, and we're done. And I'm going to have to find some nuts and bolts from somewhere, because half of them were missing. But wow, that's cost me what? A capacitor for 6p and a transistor out of a scrap Amstrad. So yeah, I mean, it wasn't cheap to get into the country, but it's the model I wanted. So I'll pause the video once again and we'll start putting it back together. Okay, so finally put it together. Apart from I need to put the wooden bits back on the paddle. And there we are. Oh, I like the key. Yeah, right. Right, well, there we are. So I'll get that into cleaned up and that, and job's a good one, and we'll be able to play with that. So something different today, the Heathkit HD10, I think they're about 1969. Thank you for watching.